Hello and welcome to the Tech Savvy YouTube channel. In this how-to video, we will be building a desktop computer. We will cover the basics step by step as well as advanced tips of professional computer building. Now this video assumes that you already know what components you'd like to use for your computer and you just need to learn how to assemble them. But if you guys like this sort of content, I would love to do a video on selecting your PC components and how they affect the different aspects of building your computer. Now the parts for today's build are an ASRock B450M Pro 4 motherboard using the AM4 CPU socket, an AMD Ryzen 3 3200G AM4 processor, an NVMe SSD drive for storage, and a 450 watt 80 plus power supply. Now we'll start our build off today by testing our core components. Now the accessories that come with any motherboard vary, but the key ones that you're going to want to look out for in any build: your I/O shield. Computer cases have a rectangular cutout in the rear. This is designed so that different motherboards could have different port configurations in the back of your computer, and these I/O shields fill in the gap of any of the unused space. This allows all sorts of configurations from different motherboard manufacturers for all of your ports. SATA cables. We won't be using these today. This is for an older standard of connecting hard drives, disk drives, and even some of the first solid state drives. This one isn't an early model, but it uses the SATA standard, and the one we're using will attach directly onto the motherboard. These screws here are to mount that NVMe drive you saw earlier directly to the motherboard. They're not commonly found within the screws included in your computer's case, so try not to lose them. If you have extras, keep them as spares and put them off to the side for now. And of course, the motherboard manual. The driver disk included in here is always out of date. We'll be getting the latest drivers from the manufacturer's website once Windows is installed. Windows 10 has a very good library of network drivers, which will make the network card on the motherboard work right off the bat. We'll be able to download all of our latest drivers and get all of the hardware components communicating properly with Windows. Now the motherboard is a great resource if you're just starting computer building. It has a lot of specifications on what your motherboard supports outside of what's included on the product page when you purchase it. It's really good for knowing exactly what speeds of memory are considered stock versus overclocked. It also has great pinouts for the RGB lighting, for where your power button, reset switch, hard drive lights are located. It's great if you are not familiar with where those pins are normally located, and it'll save you a lot of time looking at manuals online. Usually this sheet is included in the motherboard. However, it states based on how many sticks of memory you have and the type of processor, the configuration of what slots you would use. This motherboard comes with 4 slots, and it's saying if you have 1 stick, you're going to start out with the slot labeled A2. And as you move up to 2 sticks, you're going to use A2 and B2. You're always going to want to build computers in pairs of 2. This allows the memory to run in what's called dual channel mode. And dual channel mode has a lot more available bandwidth to it, and generally is this much faster than having 1 stick of memory. So you're going to want to do 2 sticks, and then if you upgrade, you want to go to 4 sticks. You never want to use 1 or 3 sticks. Usually this is included in the manual. Alright, now it's time to take our motherboard out of the box and place it on top. If you have a foam shield on the back, you feel free to take it off now. This usually just protects it during shipping. It's always good to use like a cardboard like this for the test bench. To start things off, we're going to take the processor out of the box and mount it in the motherboard. This is the stock heatsink that comes with the processor. This is what removes the heat generated when the processor is running. It's a heatsink and fan combination. And this, of course, is our Ryzen 3 3200G processor. Now be very careful when you go to remove this out of here. You don't want it flying. Any of these pins on the bottom could end up being bent, and that would cause you a very large headache. Now there's two indents on the side of the processor meant to squeeze the processor with your fingers. But before I do that, I'm going to unlock the CPU socket on the motherboard. Now, take note of the little gold arrow and make sure it lines up with the gold arrow on the motherboard. In this case, it's in my top left corner. I'm going to slowly bring the processor close to the socket, and when it comes in contact with the socket, I'm just going to wiggle it gently until it just drops on in. And I'm going to slowly put pressure on this until it locks in place. Now your CPU is installed, and that's that. Now the AMD Ryzen series and most other Ryzen consumer level processors have the pins on the bottom of the processor. This is called PGA, or pin grid array. Intel processors, their consumer level ones, use LGA, or land grid array, which means the pins are located on the motherboard and the processor has a bunch of contacts on the bottom. However, if you go to build yourself an Intel computer, the process is pretty much identical. There's a different retaining mechanism, still controlled by a lever. You have to be just as gentle. You still have to orient the processor in the correct direction when dropping it in, but the process is very similar. Now we're going to get our heatsink ready, but before we install it, there's a little thing about these retail heatsinks that drives me crazy. So I'm going to show you in a minute here. The problem I have with these heatsinks is the way they mount is like this, or like this. But either way, the AMD logo sideways, and I can't stand it. So whenever I get one of these, I always like to put it in the correct orientation like this before mounting it on the system, and I'll show you how to do that real quick. We're going to take a small Phillips screwdriver to remove one retaining screw before we actually have to pry this cover off. Magnetic screwdrivers are very helpful. Now, this clip can be difficult to come off. You have to pry it out from 3 different spots to really be able to get this thing off of here. So I'm going to start from here. There we go. Now with the magic of video editing, I'm sure I made that look way faster than it actually took me. Alright, now I'm going to use a larger Phillips screwdriver for these heatsink screws. I'm going to keep them in the same locations as where they came out of, because these screws go directly in the metal and I don't want to re-thread them when I have to insert them back into the heatsink. Now, the retaining screw hole is where the AMD logo was, so I'm just going to rotate it like this. You don't have to do a torque pattern for this, but I usually try to apply it to everything. Alright, let's put our clip back on. Now, before we install this on our motherboard, let's take a minute to talk about what this is on the bottom of the heatsink. So, in metal like this, there's little microscopic imperfections, and these create pockets of air. So if we were to just sandwich this piece of metal right on top of the processor without anything in between, there would be little gaps in between that would really lower the efficiency of the heat transfer that this heatsink is capable of. So they put on a thin layer of what's called thermal compound, and this fills up all those little gaps and makes the heat transfer much more efficient. Now the stuff that comes on here is okay, but you could spend about $8 online and get a really nice stick of thermal compound that you could use for higher end builds. I'm not too concerned about this because this is a Ryzen 3 3200G. And the processor is rated for 65 watts. I know that's not an accurate descriptor of it, but I know it's not going to generate enough heat where this thermal compound is really going to be causing a problem. I'm going to remove the existing heatsink brackets. This is for a different style of heatsink that uses two retaining clips on the top and bottom. Now that metal plate that I showed you before on the back of the motherboard is now free to fall out. Just keep that in mind when you have this currently undone, that if you lift this, that metal plate will fall out. It's not a big deal, you can just pop it back in, but it's just loose right now. So I'm going to make sure that all of our screws are properly oriented, and in this case they are. I'm going to just set it down on there, and then I'm going to wiggle it a little bit just to make sure that all the screws are settled in. Now I'm going to apply a little bit of force on the top, and I'm going to turn each screw while pressing in 5 times. You don't have to be that precise when doing this. I just like creating even mounting pressure as I install heatsinks. Done, done, and done. Now our fan needs to connect to one of the many pins located on the motherboard. We're going to be looking for a set of pins called a fan header. On current generation motherboards, they come in sets of 4, though they're still backwards compatible with the fans that might only have 3 connectors on it. I'm going to look for the fan header labeled CPU fan, and in this case it's one of these 2 right here. There's 2 of them on this motherboard. I'm going to be using the bottom one. I'm going to tuck the line in under the heatsink just to make it look a little cleaner for the build. And there we go. Now our processor, heatsink, and fan are completely installed, and we're going to install memory next. Now, as the documentation stated, when we're using 2 sticks of memory for any processor, A2 and B2 must be populated first. Now there's an offset indentation on this memory module, and the motherboard also has the same offset on the slot. So we're going to make sure those 2 line up, and once we do, we're going to take the memory stick and we're just going to place it in the slot. We're not going to set it in yet, but now it's in the slot. Now we're going to press it in. I'm going to put my thumbs on both ends and press at the same time. And when the click happens, you know you're good. I'm going to do the same for the other stick. And now your memory is installed. The solid state drive isn't needed to turn on the computer. However, since we have the board out right here, I might as well just install it, make sure it shows up after we turn on the system. This motherboard has 2 M.2 slots. When you're purchasing these components, what you have to know is what the slots support. There's actually a couple protocols that these could support, and if you get an NVMe drive, the NVMe drive works on the PCI Express bus. So you have to make sure that your slot supports PCI Express or NVMe for it to work. A lot of the M.2 slots, especially on lower end motherboards, will use a SATA version of M.2 slots, and those two won't be compatible. You need a SATA M.2 drive to work in there. I believe this top slot is a PCI Express and this bottom one is a SATA. I'd have to double check the manual, but that's usually the configuration unless you start getting more expensive motherboards. So I'm going to get started by installing the M.2 drive. I'm not going to push this down against the board, but I am going to put it into the slot. Now I'm going to get one of those screws from earlier and use it on my small Phillips. Now your M.2 storage is installed. I could also show you what it takes to install a hard drive in the computer case on the next video when we actually go and mount this in the system, but for now let's continue on with testing out these components. Now this system is ready to be tested. We could get our power supply out of the box, connect everything up, plug in our video into the motherboard and test it out. However, a lot of you out there are probably building with graphics cards and not using the integrated video on the processor. So I'm going to put in a graphics card in here just to show you how we could test it out on the motherboard. I'll also show you how to install it in the case as well. It's very easy to do. I made sure the motherboard was on the edge so that this bracket here will hang off without any problems. So I'm just going to make sure that everything lines up with our top slot. And once again, similar to the memory, I'm just going to push it in, and then the retaining latch for the PCI Express slot comes up and locks it into place. A quick note on PCI Express slots. Not all slots are the same, and it completely varies on the motherboard and the processor that you're using, what it supports. So your processor has X amount of PCI Express lanes. These are utilized by your PCI Express slots, aka your graphics card, your M.2 drive, and other miscellaneous devices that share that same bus, the PCI Express bus. Now on this board, the top slot is a full speed slot, PCI Express 3.0 in this case, at 16 times. 16 times being the highest rated multiplier. This bottom slot is PCI Express, I believe 8 times, maybe 4 times. But the pins only go up to about here. And if you could see that when you have a light over it and you look at it at an angle, I don't know if I could show it on video, but the pins in there stop there. That means this slot doesn't run as fast as the top slot. The main thing with this is PCI Express 3.0 is such a fast interface that even if you did use this, the video card probably wouldn't be able to utilize enough bandwidth to even max out this lower end slot here. So whenever you have a graphics card, usually install on the top slot, but the second slot may run slower, but it still might not be slow enough to actually affect anything. It's just a good amount of information to know about PCI Express. Now I'm going to unbox our power supply and we're going to plug everything in, and I'm going to show you how to plug in the graphics card to test it out. Here's our power supply. Now if you're watching this video because you took someone's recommendation on what parts to buy and you want to assemble them, and you need to learn a little bit about power supplies, anything that's relevant to you is located on the 12 volt rail, indicated by this plus 12V. Some power supplies have multiple plus 12Vs. That indicates it has multiple rails, multiple 12 volt rails. What really matters to you is how many amps and in turn how many watts are available on the 12-volt rail, not your total watts, 12-volt rail watts. That is how much power is available to you when you're reading guides on video cards and power and processor power draw. That's all 12-volt power, not this 5-volt and 3.3 that adds up on here. So 400 watts on the 12-volt rail is more power than this system will ever use without a video card. Now that we added a video card to it, this video card could draw in excess of 200 watts all on its own. That would leave us 200 watts for our core components. The processor might be able to peak at 100 watts on its own. Now we're over 300 for other miscellaneous parts, fans, so on and so forth. You don't want to be running that high of a load on a power supply. I don't want to be using 90% of my 400 watts because you're going to burn out the power supply faster. It's going to generate a lot of heat and it'll die sooner. You really don't want to go past 75% load on a power supply. That's my personal recommendation. Some people might disagree with that. I don't ever go above 75% when building a system. So if you were to build a system similar to this, but you wanted a graphics card that drew around 200 watts, you'd want to at least go 550. And that means at least 500 watts on the 12-volt rail. If you get a nice power supply, it's going to have a full 550 on that 12-volt rail. Now, there are two main connectors on getting this motherboard on. With the video card, there's three, but let's start with the primary motherboard power connector, the ATX 24 pin. Now, this has it split off because the older standard was an ATX 20 pin with a 4 additional. But we're just gonna hold those two together. This clip needs to line up with this lip down here, and then we're just gonna wiggle it in. You don't just want to press in and apply a bunch of pressure because these clips could be pretty stubborn and you will end up using a lot of excessive force to get this all the way in. Our next up is our 8-pin CPU power. On some of the newer boards, it could be 8 plus 4. However, that 4 is not always required to be used, so don't panic if you get a board that needs that and your power supply only has 8 pins. It all depends on the processor installed and how much power that it needs. But for most boards, it's an 8-pin connector, and your power supply nowadays, they all come with 8-pin power. Usually these lines, the yellow is 12 volt, black is ground. I'm not going to say it for fact because who knows, there could be some power supply out there that doesn't follow that, but every one I've built, yellow is always 12 volt. And same with this video card here. We have a PCI Express labeled connector. It uses 8 pins, so we're just going to plug it on. And of course, with the magic of video editing, you guys didn't have to see how much of a struggle it was to get that in there with this shroud in the way. But now this system is ready to be fully powered on, right on this box here to test to see if everything's working. You would plug in your monitor cable into the video card, you plug in your keyboard and mouse, and we'd plug in power. But before we do that, I am going to be removing this video card because I don't need to use the video card and I want to test the display out on here. So I'm pushing that clip and wiggle it out. Now this retaining clip could be a little tricky for the PCI Express port, especially if it's in a case and there's all sorts of stuff in the way. So you could try getting it out with your finger, but I'm not going to do it. I'm going to show you how I would get it out if it was inside a case, but you have to be careful. So you can use a screwdriver and you just give it a little bit of pressure. And there it is. If you put too much pressure on this clip with a metal screwdriver, it's going to slip past and it could damage one of the traces on the board, and you don't want to fry your motherboard that way. So just make sure that if you ever have to do that, just be very careful with where you're applying that downward force onto this clip. I'm going to plug in our power supply. make sure if you have a switch, it's in the off position. If you don't worry about it. Now I turn the power supply on. I'm going to connect my wireless USB receiver to the keyboard and mouse. I'm going to plug in my HDMI monitor cable into the motherboard. Now the power button that's on your case is just to complete the circuit. So it temporarily completes the circuit, telling the motherboard to turn on. We're going to pretend to be a power button with a screwdriver. I'm going to locate the pins up front. This one says PWR BTN, and it says that these top right 2 pins are the power button. I'm going to show you in a second. So I'm going to take my screwdriver, and I'm just going to briefly touch these 2. There we go. Now at this point, I'm watching the monitor to see what pops up on screen. All right, after about 15 seconds, I got the manufacturer logo. And now it has a black screen that says reboot and select proper boot device. This is perfect. This means it completed its check and it now went to go look for the hard drives to see if there was an operating system on them, which there wasn't because it's a brand new drive, but it is ready for one. All right, now we need to go into the BIOS. The BIOS is the low-level control system for the motherboard or the computer. In here, we're going to have options to be able to change the memory speed. Without getting into too much details on changing BIOS settings, it is the one thing that we have to change to make sure the memory is running at the speed it was intended to, and you're getting your money's worth, especially if you spend it on expensive, gaming memory and such. I'm going to press Control-Alt-Delete on a keyboard to reboot it from this. And depending on your motherboard, you're going to rapidly press delete, F1, F2. In this case, this computer is F2 or delete to get into the BIOS. Now this colorful screen you see is called a UEFI. It's the newer version of what is replacing BIOS, and I mean pretty much has already replaced BIOS. If you're working with older computers, you shouldn't have to worry about seeing a completely different screen and wondering what is all this. It will just be more text, basic colors, and either way, you're still going to want to navigate with the keyboard. Alright, as you can see, DDR4 slot A2, DDR4 slot B2, both have 8 gigabytes of memory. By the way, 1 gigabyte is 1024 megabytes. That's how it counts up. So 8192 is 8 gigabytes, in case you're running what the random number is for a total of 16 gigabytes. Now, you can see it's running a DDR4 2400. That's the default speed that this motherboard chose to run the memory at to boot up. However, this memory, as we talked about earlier, is DDR4 3200 and is running substantially slower than it should be. So I'm going to show you real quick how we go through and make that memory run at the speed it's supposed to. Alright, now this varies based on what motherboard manufacturer you have. But for this ASRock board, I go into the overclocking section. Sometimes it's right on the main page, sometimes it's called different things. I think there was MIT for gigabyte, I think is what they call theirs. But either way, you want to go into a section where you could start modifying speeds. And this board is called the OC Tweaker. I'm going to go down to Load XMP setting. XMP refers to the memory profile or extreme memory profile stored within the memory stick. As you can see here, it read that the profile stored here is DDR4 3200, and these numbers here represent their timings. Timings also directly have to do with and of course the voltage that the memory module is run at. So I'm going to click on this load XMP setting with the enter key. I'm going to switch it over to that XMP profile. It now says the frequency will be running at 3200 from its current 2400. Whenever you want to apply settings in the BIOS, just hit F10 right at the top of the keyboard. Go ahead and hit yes. Make sure you're on yes, because sometimes it illuminates the other one and it looks kind of tricky, but enter on yes, and now it'll be running at 3200. In the next video, we're going to be installing all of this into the computer case. And then we're going to do full cable management to make the entire inside of the computer look beautiful. And you can be really proud of your work when it's all done. Following that video will be the last one for this series. And that will be installing the Windows operating system, making sure everything's running as smooth as could be. We could test the hardware in Windows to make sure it's fully stable. And then you'll have a fully operational computer that you picked your parts and assembled yourself. Now, if you guys like this video, please like the video, comment about it, subscribe. It'll let me know that you guys like this sort of stuff and you like the way that I'm presenting it to you. By letting me know that you guys are interested, I'll know that I should extend this series further, and I'll do PC part picking videos. So you can learn to pick parts based on gaming requirements, business use, production systems like video editing, and you will be able to build these systems yourself after ordering the parts yourself. You could even get into selling these units if you'd like. You could build them for friends and family. It's a great hobby to get into, and I've enjoyed it for years. But not to get too carried away, thank you again for watching, and I'll be seeing you guys soon.